Alright, we have gasp, groan, word problems now. But we're going to just take them slow, and we're going to realize that everything that we need to know is in the word problems. We just have to take our time and find it. So let's talk about this. We have two kids. Pam, maybe they're not kids. I don't know. Pam is 12 years younger than Jim. So I would suggest you get out your notebook and copy these in. Pam is 12 years younger than Jim. Let's see what else we know. Their ages, the sum of their ages is 34. How old is Jim? I'm going to change my pen because I want it a little thicker. There we go. Alright, did you get that written down? Okay. So, Pam is 12 years younger than Jim. The sum of their ages is 34. We just need to kind of go through it. Keywords. Pam is 12 years younger than Jim, so we know Pam's the younger person. That might be important or not. The sum. When we see the word sum, we need to think of addition. So let's just start off by saying that Pam's age plus Jim's age equals 34. And it's really nice if we do this. P equals Pam's age, not Pan, Pam's age, J equals Jim's age. Especially if you have something like this as an assessment, you would want to definitely, it's what they call defining the variable. What does P stand for? What does J stand for? So we know that they are added together. And now we also go back to this first sentence. Pam is 12 years younger than Jim. So if we take Pam's age and we add 12 years to it, it should equal Jim's age. This is probably the more difficult one to think about, but it's just tearing it apart. How can I make Pam equal to Jim? What do I need to do to that? Alright, so what we know is that J equals P plus 12. So what we're going to do is we're going to take this P plus 12 and we're going to substitute it into this equation up here where there's a J. So when we rewrite it, P plus J becomes P plus 12 equals 34. Now this is just an algebra problem. 1P plus 1P, that gives us 2P's, plus 12 equals 34. This is your basic two-step algebra problem. We need to get rid of the 12, so we subtract it from both sides. When we rewrite, we have 2P equals 22. 2P's equals 22, so we need to get rid of the 2. We divide to undo the multiplication happening. So P is going to be 11. Are we done? Well, let's see. P stands for Pam's age, and Pam is 11. What did they ask us in the question? How old is Jim? Oh, we're not done. But Jim is 12 years older than Pam. So 11 plus 12 gives us 23, and that is going to be Jim's age. There you go. So it's a matter of kind of just combing through what they're giving you for words, trying to translate them into some kind of an equation, and then solving it with algebra, which you guys should be pretty good at, and then just making sure you answer the question at the end. Alright, let's try another one of these. Let me slide this up. Alright, let's see. Let's do a problem with tickets. There's just like always problems with tickets being sold. Let's say that there was a concert, and altogether there were 368 tickets were sold. And what else? Let's say that the number of student tickets, sold, I'm going to abbreviate tickets, T-I-X. Number of student tickets sold was 3 times, or triple, the number of adult tickets sold. You're writing this down, right, in your notes? I hope so. How many adult tickets were sold? That's what we need to find out. Whoops. Alright, got that written down? Alright, if we need to pause it before I go on, you do that. 368 tickets were sold. The number of student tickets sold was 3 times the adult tickets sold. How many adult tickets were sold? A lot of words sold in there. It kind of bugs me. But let's look. We have two different things, right? We have adult tickets, so we'll let A equal adult tickets. And we have student tickets, so we'll let S equal student tickets. If you want to use X and Y, I don't care. It doesn't matter to me. So altogether there were 368 tickets. So all of the adult tickets plus all of the student tickets has to total 368 because that's how many tickets they sold. What else? Second sentence. The number of student tickets was 3 times the number of adult tickets. So can we say that students equals adults? Is that valid? No. Let's figure that out. The number of student tickets was 3 times the number of adult tickets. Alright, so student tickets, there were a lot more sold, but if we multiply the number of adult tickets times 3, now it's equal. Student equals 3 times the number of adults. Bam. Alright, so what we're going to do is, since this is solved for S, we have an S here, we're going to take 3A, which equals S, and plug it in there. Why? Because then we'll have all A's in this equation. If we have all A's, it's simple algebra. If we have an A and an S, I don't know how to solve that. So we're going to change the A plus S equals 368 to A plus 3A, which equals S, equals 368. Now we have an algebra problem. 1A plus 3A gives us 4A's. How do we solve this for A? We need to get rid of the 4. The 4 is multiplying, so we divide. What we do to one side of the equation, we do to the other. And when we divide that, we get 92. So are we done? A equals 92. A is the number of adult tickets. And they asked how many adult tickets were sold. Absolutely. So 92 adult tickets were sold. Alright, so just slow, careful analysis of each sentence. In this type of a problem, it is your task to come up with some variables. You're going to have to come up with them. Most of them they have 2 variables. Figure out what they stand for, and then try to analyze each sentence and coming up with equations based on the word there. That's basically your task. Let's try one more. Alright, let me slide this guy up. Alright, and for this one we'll talk about hamburgers. We have a shop that sells hamburgers and cheeseburgers. Altogether, let's say a shop sold a total of 803 burgers. That includes hamburgers and cheeseburgers. Let's say 53 more cheeseburgers were sold than hamburgers. I wonder why they call them hamburgers. It's not made with ham. Alright, and the question that we want to know is how many hamburgers were sold. Not 803, because that included cheeseburgers and hamburgers. Hamburger. How many hamburgers were sold? I love the Pink Panther with Steve Martin. Oh, I would like to have a hamburger. Alright. Got that written down? If not, pause it, write it down, hit play again. Shop sold a total of 803 burgers. Alright, so we have 2 different kinds of burgers. We have cheeseburgers, and I'm just going to abbreviate CB, and we have H for hamburgers. A total is going to tell us to add them, right? All of the cheeseburgers and all of the hamburgers totaled 803. That's a lot of burgers. So now we need to get a relationship between cheeseburgers and hamburgers. I just like to start before I even read the question. Does C equals H? I don't think so. 53 more cheeseburgers were sold. So there were more cheeseburgers. So if we add 53 to the hamburgers, then these guys will be equal. The number of cheeseburgers equals the number of hamburgers plus 53. Totally. Alright, so for C, which is here, we have H plus 53. So we're going to take out that C and put in H plus 53. Why do we want to do that? Because then we'll have an equation with only H's in it, and having one variable to deal with instead of two is going to help us use our algebra skills to solve it. Alright, so we have h plus 53, that's for the c, plus h equals 803. And now we use our algebra skills. We have an h plus an h, that gives us 2h plus 53 equals 803. Hey, we have a two-step basic equation. Subtract 53 from both sides. And I'm going to swing this over here because I ran out of room. Now we have 2h equals, that would be 5, 750. We need to divide both sides by 2. And h is going to equal 375. Did we answer our question? H stands for hamburgers. We know 375 were sold, and they're asking us how many hamburgers are sold. Yep. So there were 375 hamburgers that were sold. That's a lot of burgers. Alright, I hope this helped. If you need any clarification on something, come find me, and I'll try to help you out on that. Bye.